Welcome to all. This class we will discuss about moldings and ingredients. First we will discuss what is molding. The process of making mold is called molding. The various steps involved to produce a mold, the particular mold, it will be help to produce a quality of component without defect free. It includes filling molding sand around the pattern, ramming, removing the pattern. Once the ramming was over, finally remove the pattern properly without damage. Then to pour the molten metal in the mold cavity to get that component. So it includes filling the molding sand around the pattern, ramming, removing the pattern, making runner, riser, gate, it's a passage, vent holes. So these are the steps to follow to get that good mold cavity from the pattern. Molding sand. Molding sand is an important material. So the what are the elements to present that molding sand? Based on that we get that quality of product. It can withstand a high temperature of molten metal. After it permits gases and air to escape from mold when the molten metal is poured. Once we prepare that mold, then we pour the molten metal through the runner, the particular molten metal to reach that mold cavity. Once the mold cavity is filled, we raise that riser, then look at the top of the surfaces, then you have to stop that. After some porous is available in that sand, so the particular porous it will be help to allow the gases air from that mold. So this process is help to get that quality of that component or product. Next, molding sand ingredients. So molding sand contains silica, clay and moisture. 80 to 90% of silica, 5 to 20% of clay, generally 2 to 5% of water is added to sand. Binder. Binder is added to molding sand to obtain that cohesiveness. So each and every particles they are individually. So with the support of binder, you have to blend that particles, sand particles. The sand particles are joined to is called as cohesiveness. Binds the sand particles together and give the strength of the mold. Then only to give that strength of that particular mold. When you have to ram, so easily to stick that each and every particles to give that good bond. Uh, Various types of binders available. The clay type binders bentonite, organic binders examples of wood, resin, dextrin, inorganic binder, Portland cement and sodium silicate. Additives. Generally, additives are added to molding sand to improve the properties like strength, permeability, and refractiveness to withstand that particular portion. Then only to get that good shape and size of that components. Here we use that reducing agents to prevent the formation of oxides. Fill up the fine pores of that mold surface to get that good appearance. You have to use that coal dust. Then we use that fibrous material, prevent the formation of a dry surface, improves that collapsibility. Collapsibility means once that process is over, have to produce that mold cavity, pour the molten metal to get that shape, the process is over. Then you have to broken that molding sand box. So that time the molding sand it will be helped to uh, collapse. So that terms is called as a collapsibility. Generally use that wood floor and cow tongue. The special additives prevent quick drying of the mold is used dextrin. Next, classification of molding sand. So natural sand or green sand. Generally, the sand is collected from that river bed. It contains silica, 5 to 10% of clay, small amount of lime, magnesia. The main advantages of this particular sand to collect from the river easily to available and cheap. So these are the main advantages. Mostly they are preferred for use for natural sand. Synthetic sand to obtain required property by adding ingredients with the natural sand. So to add some elements for natural sand, bentonite, calcium and magnesium are mixed with that natural sand. So it's called as a synthetic. Advantages: easy to mold and high refractoriness. When we need to high refractoriness, at that time we go for that synthetic sand. Next, special sand to obtain record specific properties, high heat conductivity and low expansion. So that time we use for the special sand. So examples various sand is given: olive sand producing non-ferrous castings of complicated shapes. Non-ferrous means aluminum, magnesium, copper. That type of materials you have to melt and pour. That time we have to prefer for that olive and sand. So complicated shapes, if you want to, that non-ferrous, mostly they prefer. Zircons and making cores required for brass and bronze castings. Making core, if you want to hollow in one object, that time mostly used for core. That time we prefer for that zircon sand. Next, chromate sand, the facing sand. Facing sand means when you have to pour that molten metal, that immediately to contact the surface is called as a facing sand. So the facing sand to need high withstand that temperature. So that time we use that chromate sand. Thank you.